Let's begin. Today's June 13th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and it's 6 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 6 criteria cards. Criteria card 6, 9, 13, 18, 19, and 20, and uses the purple verification cards. This code is your way to get more information on today's puzzle by doing a search on turingmachine.info. Let's solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C. And in the second row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at that middle digit, the square digit, and will let us know whether that value is an even or an odd digit. Criteria card B looks at the 3 digits in our code and will let us know how many of those are 3s. Are there no 3s? Is there 1, 2, or possibly all 3 of them are 3? Criteria card C will compare the middle and last digit, the square and circle, and basically will let us know whether the square value should be less than circle, perhaps they're equal to each other, or the square is greater than circle. Criteria card D will again take the 3 digits, triangle, square, and circle, add them together, and the Turing machine will let us know whether that sum is an even or an odd quantity. Criteria card E looks at the first 2 digits, takes their sum, and compares that to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will again look at our 3 digits in our code and will let us know a little bit about its structure. So, for instance, are there no repetitions among the digits, meaning that they are all unique, as in the example 125? Or is it a double number where a digit is repeating, as in the example 112? Or is it a triple number, meaning it's a single digit repeated 3 times? Remember, the objective of today's puzzle is to find this unique 3-digit code that abides with all of the criteria cards that we just described. And we're going to begin with our proposal of 314. So the first thing I want to test is I want to find out if that middle digit is an even or an odd. So I'm going to test criteria card A. Okay, so the Turing machine does not approve. So if we go back to my proposal, notice that I have a odd 1 in for square. Since the Turing machine does not approve of it being an odd, that means that square is actually an even digit. So that's what I'm going to write down in my notes in section A. That square is an even digit. And since it is even, I'll come up here and cross out all of the odds. So it can't be a 1, can't be a 3, and it can't be a 5. Okay, what else? So let's go ahead. I want to test criteria card F. I want to see what's the structure of our 3-digit solution. And so let's test criteria card F. Okay, so it does not approve of my proposal 314. Notice that 314 are all unique, so there's no repetition, but the Turing machine does not approve of that. So either it's a single digit repeated 3 times, or it has a double. So let's go ahead and put that in our notes. Let me give it let me think about this for a second and see if there's anything in here that would sort of invalidate the triple number. Well, I guess if it's a triple number, that means that, of course, square would equal circle. That would be obvious, and so this card would not give you any additional information. So I think there's a rule about Turing machine gameplay where if that's the case, if you can somehow make a card irrelevant, then that means that this cannot happen. So I think we can say that there must be a double number. So that's what I'm going to put down in my notes for criteria card F. So there is a double number. Okay, so, and we don't know if it's two evens or two odds. And it doesn't mean that you can still have three total evens and three total odds. There's nothing that says that. It's just that it's not a single digit repeated three times. But I think that maybe if I use criteria card D, it may help us to have a better idea of the structure of our code. So let's give that a try. Let's give criteria card D a try. Okay, so it does approve of my proposal 314, and so if we add up the digits, 3 plus 1 is 4, 4 plus 4 is 8. That means the Turing machine is telling us, yes, the sum of the three digits is an even quantity, 8 being even. So let's go ahead and write that down in our notes for section D, that triangle plus square plus circle is an even quantity. And circle is equal to an even quantity. Okay, so what does that tell us? So it basically means that, well, if we consider square being even, that would mean that triangle and circle are both going to be the same type of number, meaning that triangle and circle can both be odd, because when you add an odd value, that becomes even, and when we add the square, the even square, our total sum remains even. But at the same time, triangle and circle could also be even, right? If you add up three evens, it's even. So basically, triangle and circle have to be the same type of number. Not sure how that really helps us, but at least it's something to keep in mind going forward. And we have already done our 3 Turing tests for this round, so that phase is complete. I don't think we can actually eliminate anything based on our results. So we're going to the phase where we're going to think through and construct a good second round proposal. Okay, so we did test 3. So there is an odd, as I kind of mentioned earlier. That means that in this case, it would have to be a double 3. Remember that since square is even, if triangle and circle are odd, they would have to be the double number if they were odd. So that's interesting. So yeah, so it would have to be 1, 1, 3, 3, 5, 5 if they were even. Sorry, if they were odd. I apologize. But if they're even, then we don't know how it's going to be paired up. Square, triangle, square, or triangle, circle, or square, circle, where they would be even. So that's something to consider. There are either no 3s or 2 3s. You can't have just a single or even a triple. So that'd be interesting that if you don't have any 3s, then, well, I guess that makes it 1 1 5 5 if it were odd. Let's see, what about criteria card C? That's comparing the first and last. Well, in case they're all even, it would tell us that, it would either be 2 2 or 4 4. And then obviously triangle would be the other even digit, whatever that might be. And criteria card E could help us in that. It could be that triangle and square add up to be 6, so there's some 2 and 4, and then you'd be comparing the evens in square and circle, and then somehow deducing what triangle would be. That would be interesting. So I think that's what I'm going to do. I'm going to say, I think they're all even. That means there are no 3s. I guess, well, okay, let's consider for one instant if they are 3s. If there are 3s. So it'd be 3 on top and 3 on the bottom. And then somehow, what would that mean? Well, that would mean that circle and square, you could figure out what it would be. Would it be 2, 3 or 4, 3? But I don't think that's going to be the case, just because, once you know that, it's almost like the criteria card C and E are 2 related, right? I know that sounds funny to say, but so I'm going to go with, again, I think that triangle and square add up to 6. Is that any better? I'm not sure, but I'm going to go with it. So let's say it's going to be 2, 4, well, even that. 2, 4, 2, well, of course, it'd be 2, well, you don't know if it's 2, 4 or 4, 2. Yeah, I'm going to go with that. I'm going to say 2, 4, 2. And let's see where that takes us. Okay, so the first thing I do want to test is that criteria card E to see if the sum is 6. Okay, so the sum is not 6. So let's go ahead and write something down in our notes about that. So triangle plus square, triangle plus square is either less than 6 or greater than 6. Okay, so the good thing is that we can then say that triangle and square have to be, well, no, not necessarily. I was going to say that they have to, they would have to be odd. But no, I guess technically you could have 2, 2, which adds up to 4, or 4, 4, that adds up to 8. That's less than 6. That's greater than 6. Well, I guess we could test B and find out if they're both 3s or no 3s. So if there are no 3s like I have, then it still doesn't say much about what triangle and circle would be. Let's see. All right, well, let's just go ahead and test criteria card B, and let's see what it says. Okay, so that is correct that there are no 3s. So let me go ahead and put that in our notes, that there are no 3s. And so, yeah, so let me go ahead and then cross out all the 3s. Now, again, it doesn't mean that there aren't any odds. Let's see, anything else about the sum? Yeah, I think there's still too many possibilities. 1 and 4 is less than 6, 2 and 4 is 6, and then you have 4 and 4 and 4 and 5 that add up to something greater than 6. Well, let's go ahead and I guess test criteria card C. and because at this point I'm still not sure what's going on. So let's go ahead and test criteria card C. Okay, so it does approve, and so basically again we're comparing the middle and the last. If you notice, my square is greater than my 2, so that means that square is definitely greater than circle. The Turing machine approves of that. So let me go ahead and write that down in C. That square is greater than circle. And so let's see, what can we eliminate from that? So if square has to be bigger than circle, then circle can't be 5, right? Circle would not be bigger, as well as 4. Circle can't be either 4 or 5. Okay. And so, yeah, so square is greater than, 2 is bigger than 1, and 4 is bigger than 2. Okay. Well, we're done with our 3 tests for the second round. I guess we're going to a third round unless I can figure out what the answer is. Well, let's see. We can also cross out the 5 because remember, it would, well, let's see, could it be? No, I guess technically it could still be a 5. It could be 5, 2, 2. Okay. Well, let's see. So 1 can be doubled, the 2's can be doubled in several ways, and 4 could be doubled. I wonder if it's worthwhile to start listing some choices here. Well, let's see. If I were to say 1 is doubled, then let's see, so the middle would be even, there are no 3's, and in both cases each of the squares are bigger than the 1. Their sum would be even, and even their triangle and square 1 and 2 and 1 and 4 are also, let's see, oh, well, yeah, they're both less than 6. So that means that that's an ambiguous solution. So I don't think the triangle and circle could be both 1. I don't see any way of distinguishing them based on our 6 criteria cards. They all, both of those patterns, 1, 2, 1 and 1, 4, 1, there's nothing in our criteria cards that could distinguish them. So I feel confident that we can cross them out. I don't see how they could be in our solution. Okay, so that means, if you notice, that means that we have all evens. So that 5 then can be canceled. Yeah, I should have canceled it a long time ago, because even if I said the 2's could be paired up, that sum would be odd. Yeah, I should have crossed that out much earlier. Okay, so, and we know that the sum is not 6, right? So that means that we do have much fewer options. So let's go ahead and list them out. Let's see. Can I come here and start? So we could have, well, we can't have triangle and square be 2 because we don't have a triple number. Again, earlier in the video we stated that if it's a triple number, this would be irrelevant because it would be equal. So that means it can't be 2, 2. It could be 2, and it can't be 2, 4, 2. So I don't think triangle can be a 2. That must mean that it's, actually that may be, let's see, so it's either, yeah, it's got to be 4, 4, 2. I don't see any other combination of numbers. So again, if triangle were 2, square could be 2, but then there'd be nothing for circle to pick. And you can't do 2, 4 because that was 6. So yeah, it can't start with a 2. It's got to be 4. And it can't be 4, 2, 4 because there's no 4 for circle. So yeah, it's got to be 4, 4, 2. Wow. I had no idea that we could have deduced it. Okay. Well, I'm glad I tested those ones. So I guess that's what I'm going with, 4, 4, 2. And so that would mean that I'm sort of deducing that the sum is greater than 6. But I'll leave the notes as is. But just to go over everything, yes, the square digit, the middle digit is even. There are no 3's. Our square is larger than circle. That's correct. The sum of the 3 is even. Again, we're deducing that the sum is greater than 6 and that there is a double number. Okay, well, let's go with that. 4, 4, 2. So 4, 4, 2. Scroll down to verify. Okay, fantastic. So we got our solution. Now, did we beat the Turing machine? So we did do 6 tests, and there were no redundant tests, so we didn't do one of them twice. So let's see, we did do ADF first, and then BCE. So ADF. So we did ADF, and then in the second round we did BC, and both B and C were correct, but E was not. So let's take a look. Okay, wow, fantastic. So we did it in 6 questions. The Turing machine did 8. And so, yeah, that was a great win. I'm actually a bit surprised that we did do it in 2 turns, 2 rounds. I was really thinking we had to go to an additional round. I guess our saving grace was that we actually tested the 1-1 and confirmed that they gave us a couple of ambiguous solutions, meaning that we couldn't distinguish them based on, they complied with all 6 criteria cards. So when you have 2 solutions that do that, neither of them could be viable. Remember, we're looking for a unique solution. And so luckily we did test that, and we were able to eliminate it. And so, wow, I just am, very glad that it worked out the way it did. Well, if you liked the video, please do give it a thumbs up. If you saw anything and would like to add anything to the comments, please do so. I'd really be interested in hearing your opinions and your thoughts. And if you don't want to miss out on any future videos, please do subscribe to be notified. Well, until next time, have a great one.